Let's have a look at question 12, also from the extending trig topic test, because a lot of people struggled with this one. We need to show that 2 lots of the inverse cos of 3/4 equals the inverse sine of 3 root 7 on 8 without using a calculator. Now, have a look at the big picture before you start. We've got 2 lots of an angle equaling another angle. We can also see that both of these angles must be in the first quadrant because the cos of this angle is positive and the sine is also positive over here. So both of these are different angles. They're both in the first quadrant. And if we want to do 2 lots of this angle and it needs to equal this angle, then this angle here is going to need to be less than 45 degrees so that when we do 2 of them, we've still got an angle that's in the first quadrant. So at some point, whether you do it at the beginning or at the end, you're going to need to show that approximate size. So I think I'll launch into that at the end, but I've already thought it through at the start, so I know where I'm going with it. Now, it's not easy to prove that 2 lots of this equals that, but if we take the cos or the sine or the tan of both sides, we can use our double angle formulae to do this. So take your pick of any of the 3. I seem to often pick cos. So I'll write down at the start what I'm going to prove. I'm going to prove that the cos of this side is equal to the cos of the other side. And that way I can prove that both sides are equal. Okay, so similar to in question 10, let's let each angle equal, say, alpha and beta. So let's let the inverse cos of 3/4 equal alpha. Therefore, we can say that the cos of alpha is 3/4. And there we can draw a little right angle triangle and we can put alpha in it. And we can say that if cos of alpha is 3/4, we can use Pythagoras' theorem to say square the 4 and get 16. Subtract the square of 3, that's 9, and we'll get 7. So over here we have the square root of 7. So therefore we can say we've got cos alpha. We can also find sine alpha and see that it's going to be root 7 over 4. We can let the other angle equal beta. 3 root 7 on 8 equal beta. So therefore we can say, that the sine of beta is 3 root 7 over 8. We can draw a little right angle triangle. We can put beta in it, and we can say that if the sine of the angle is 3 root 7 over 8, then if we square 8, that's 64. Subtract this squared, which is going to be, 9 times 7, that's 63. Well, 64 minus 63 is 1, and the square root of that is 1. So therefore we can say that the cos of beta, we already know the sine of beta, so let's find the cos of beta, is 1/8. Okay, so we sort of have that as a little standalone section where we're basically generating the ingredients that we're going to need to prove this. Okay, now we can launch into it and say, all right, the left-hand side is equal to the cos of not this complicated thing, but let's remember we've called this angle alpha. So we can say left-hand side equals the cos of 2 alpha. And we've got a formula for that. In fact, we've got 3. I'm going to pick cos squared alpha minus sine squared alpha because I have both of those things. And then we can say that's equal to, what have we got? 3/4 squared minus root 7 on 4 all squared. And simplifying that, we get, 9/16 minus 7/16. So we end up with 2/16, which is 1/8. So we'll stop there. The left-hand side is equal to 1/8. Okay, what's the right-hand side equal to? Let's do that over here. The right-hand side is equal to the cos of, what did we call this? Beta. So this side is really easy to do because cos of beta is looking at us here. We've already figured it out. It's 1/8, and that is equal to the left-hand side. So now the only other part that we need to take care of is just checking that the size of the angles is going to work, because we need to prove this without a calculator. So what we basically need to prove, we need to show that the inverse cos of 3/4 is less than 45 degrees. Well, let's just write it like this, less than 45 degrees. Okay, because, and just make it really clear, just write it out as a sentence, because 2 multiplied by this angle is in the first quadrant. Now, if you're thinking about the fact that the sine of this angle would still be positive if it was in the second quadrant, don't forget that we've named this angle beta And then we've come up with the cos of it as being a positive number. So our proof is sort of leading towards the fact that for this to work, beta has to be in the first quadrant. And that means that alpha has to be less than 45 degrees. Okay, so what do we know about the cos of something being 45 degrees? Write down what you know. I know that the cos of 45 degrees is 1 over root 2. And I know that the cos of an angle decreases between angles of 0 and 90. Now, how do I know that? 0 and 90 degrees. The reason I know that is because the cosine curve does this, and here's 90 degrees here, pi on 2, and so as I'm looking at angles getting bigger from 0 to 90, the cos of that angle gets smaller. So if I want to check that this angle is actually less than 45 degrees, then I need to check that the cos of it is actually going to be more than the cos of 45 degrees. So compare 1 over root 2, because that's the cos of 45, and 3/4, which is the cos of our angle. Well, how do you see which is bigger out of those two without using your calculator? Quite simple, just square both sides. Write down what we're doing. Square both sides. And we can see that if we square this side, we get a half. And if we square this side, we're going to get 9/16. And 9/16 is bigger than a half. Therefore, this angle is actually smaller than 45 degrees, because larger cosine of an angle means smaller angle. So therefore, alpha is less than 45 degrees. Or you could put in here, instead of all of these degrees, put pi on 4. Look a little bit neater and keep working in radians. Same in here and in here. But literally this is an explanation for what you've done and why it makes sense. So using degrees in here is really completely fine. And writing sentences to explain what you're doing is sometimes quicker and easier than thinking of how to show it with the right symbols. So don't be afraid to just explain your thinking on paper.